and this is again a part of assignment, and it's a kind of interesting when you'll get the flow. Okay, let's talk about block-wise layout. Okay, so as I told you, block-wise layout is nothing as we did for LPDDR4 and RK3399. So I'm just going to demonstrate. Let's suppose we have to do the block-wise layout for this SD card connector, right? So what you have to do, you have to split it, go to the schematic page. This is the SD card connector, right? So again, we know that this is the regulator that we're going to use for SD card. So that means it is kind of placed closer to the SD card, because this supply is going to that only. We're not using it anywhere else, right? So there's no point to place it very far from that. Apart from that, we have this connector and these ESD diodes and few bypass capacitors, right? So what we're going to do, we're just going to select all the components.
People who don't know which tool I'm using, it is Altium Designer 22.1, and if you wanted to get the free trial of that tool, I put link in the description. You have to just click there and register yourself. Within 24 hours you'll get the license. PDN Analyzer tool is a separate license from Altium Designer. So for that I have put a separate link. For purchasing PDN tool license, you have to click over that link. With that said, let's roll the intro.
Right, these are I guess all the components, right? And we're just going to place it outside, right? Now another step is just do whatever the plan is. The plan was we have to place the SD card connector in this section. We'll kind of redo that. So this is a small circuit, right? So I'm just giving you a small example here, and you have to just replace all these components and then go for the layout, right? So you don't need to lay out all this section here, right? We're just going to do the block wise layout. So let's select these as well. Let's place those together. I don't know why this error is coming. Hold on. Okay, this is again from the software end, I guess, something. Okay, anybody wants to tell me like what should be the perfect position for placing the ESD diodes? Anyone? Like why I placed it here? I've seen so many people placing ESD diodes behind the connector, right? So when we do the layout, what we do, we just connect those. Sorry, it will be connected through vias. But yeah, this is I guess we have to implement the design rule here for SD card. Hold on, let me do that quickly. So design rule was for 50 ohm, right? We can see that from double click on this and navigate to other side of the connector, which is here. So it has like 50 ohm SDMMC net class, right? So just go to the design rules, and that will be implemented on the width, right? So for width, right now we have implemented for DDR, data address and control. Let's create a new rule, and that will be for the SD card 50 ohm. Okay, what will be the net class? Net class will be same, this one, right? It was SDMMC, right? 50 ohm SDMMC. Okay, and what will be the profile? It will be 50 ohm profile. Apply. Okay, okay, so this will be like taking so much time, and it will just, this time span will be like keep increasing when you'll keep routing all the connections. So let that check the constraint. Okay, I'm just going to cancel that for now, and let's see the design rule is implemented. Okay, this is implemented now. See, so what people basically do, they just place these ESD diode behind the connector, right? So what is the purpose of ESD diode? Whenever there will be like electrostatic discharge through the connector, right? It will be just go first to the ESD diode, then it will all the electrostatic discharge will pass through the ESD diode rather than traveling throughout the all connections, right? And it will create like a lot of issues, and it can create a huge fault as well, right? So when we'll do this type of routing, what will happen? And when we do when we start routing the connection, we'll route from this section, right? So you can clearly see this ESD diode is connected on this pad, right, which is behind this thing, right? So that means, and another solution is, we'll place it here, right? So that means you can see when the electrostatic discharge will will be on the connector side, right? It will see the diode there rather than some other component. You're getting it? When we'll connect two branches on the same pad, right, there it will just search for lowest impedance path, and wherever it will get that, there are very high chances that it can attack on the other side of the connection rather than doing toward the ESD side. You're getting it? So that's why. So you can say there is no scope of bypassing this ESD diode if you place it like this, right? So you have to decide by your own, like where should be the correct placement of all these components. All right. Again, as I did for this one, you have to do the connections quickly. Right. Apart from that, we have few more components to place. Let's place those. So let's see, where is that connector? All right. And we have this regulator. Okay. So again, this is like very small circuit. So at the time of first placement, I have kind of planned this where I have to place this component, right? So we have like not so much area free in this section, right? So, and the 12 volt, or you can say most of the, if you remember the block diagram that we did on earlier session, all the regulators and PMIC will be powering through 3v3 system, right? And that 3v3 system is coming from a buck converter, and that input is, I guess, it's a 5 volt, right? So you can see everything is coming from 3v3. So from where we can understand, okay, all these PMIC, all the regulators, all these you can say MIPI connectors, right? These all are powering through 3v3, right? So that means there will be a thick copper, or you can say the section of the power plane, which will be around like this, right? So from that idea also you can able to understand, okay, this is the right position to place all these regulators, which is only purpose to supply the SD card thing, right? So select it and just place that quickly. And here we're going to use little bit thick connections. So, and this is the input side, right? So it is at this side, so it will be easy to connect with the cross section to the section of the power plane. Okay, there is one more component. What is that? Okay, it's a series resistor, and that we can connect. Okay, it's the same here, so we'll just connect it like this. Okay, so here we have like ground pad, and that will be like directly connected to the plane. We're just going to place a thick cross section here, and we'll place couple of VRs, right? So that's why we can use this section for routing this thing. right? So I hope you're getting the idea of doing the block-wise layout, and that will be connected to this section. So for that, we have to just place. So I'm just going to log this first, and here we're going to place a thick copper, or you can use polygon pore, or you can use fills as well, right? And that will be connected to this section. Or for now, just place a thick track. Later we'll do that. This is also a kind of option that you can do. So for now, just place, hold on, we have to place at least, okay, so again, for SD card, so there are like two ways to place, decide the width of the track. Okay, you have to figure out what is the max amount of current that going to flow, right? And if you are using Saturn PCB or some other tools, right? So they also kind of consider some offset, right? Or apart from that, there is another option. We know that by common sense, okay, SD card is not going to take like more than 1 amps, right? 1 amps is even huge, right? So for 1 amps, what should be the width of the track? Anyone remember that? What should be the width of the track for 1 amps? Anyone? Okay, so it should be around 20 mil, 20 to 15 mil will work, right? So we're just going to use that. Okay, and we can use this here, this place. Okay, so for power, we're just going to use the bigger VRs. Okay, as I told you, because these type of VRs is for high speed signal, and where we'll feel like very small constraint there. We can't place bigger VRs, for example, in case of SOCs, right? For power, where we are talking about supply, we're just going to use bigger VRs. Let's go for 0.8 mm cross 0.4 mm. Okay, and we're just going to place it here. Okay, this should be through hole. Obviously, we have to connect two components. One is on the top, another is on the bottom layer. So, all right. Okay, we have to change the net name as well. Okay, and let's connect this. Same thing, we're going to connect that for this thing. Okay, so this one via is kind of enough, but we can place one more when we'll do the polygon pore. We can place one more in this section. Apart from that, let's connect these as well. Okay, this is one more capacitor. These are all the same value of capacitors. Okay, so okay, all right. Here I did one more mistake. Just to complete this section. Hold on. So what you have to do, you have to place it somewhere here, right? Because all the power, all the supply, or you can say the input on the SD card, that should be coming from all these capacitors. Okay, so if I'll place few capacitors here and I'll just connect it directly in this section, so that means you can say only one capacitor is connected on this line. So there is no a point of placing so many capacitors there, right? So it should be in this section like this, like this. You're getting my point, right? Okay, so now you can say now it is fine. So just take care of these small things during the layout. Obviously, you don't need to just connect everything. You have to just take care of the sequence as well. Okay, so this is the ground. Everything will be, so what for ground I would suggest, just place this size of VR and a very thick connection, and just connect that to this thing, the ground plane. Okay, and this is the pin which is going somewhere on SOC. Here it is, right? So again, this is not a part of block layout, blockwise layout. So okay, so this is the thing. This is a kind of example of placing the block, and I'm just going to do that as well. So whenever you are doing the connections layout or anything, just keep doing the ground as well. Okay, I guess the ground net is not assigned to the ground plane. So for that, what you have to do, Firstly, I'm just going to merge that, go back to a PCB, start from ground 1. Okay, you have to double click on this and you have to select the ground net, right? So just search G, here it is. Okay, similarly you have to assign the ground on this plane as well, so double click, and we have so many grounds, and one more. Okay, so if you remember, we have one section, or you can say we have one a block of schematic that is DAC, and you know, that we are using for connecting the headphone and speaker, right? So that section will have analog ground, right? You have to plan it accordingly so the return path of analog and digital will not clash. So how we plan the analog ground? Okay, so that means this section of the ground will be isolated, okay, and only this section you can make it open. So you can see the current flow will be in this direction only, right? You're getting it? So when you will be using the via, make sure, okay, so like there are type of vias on which we can, you know, remove the pad if you don't want to connect all the ground planes together, okay. But yeah, at the end everything will be connected. So this you can do. You can, so we have like 4 or 5 ground plane. You have to place a, you know, fill, or you can say a thick line on that. Okay, so that will create the isolation on the ground planes. Okay, that I will demonstrate in very detail during the when I'll record everything. But yeah, that you have to plan. Okay, another thing is just completely isolate this, completely remove this section. And what you can do, yeah, you can you know, create multiple section on the ground. So one will be like digital ground, another will be the analog ground, right? And there you can place either, you know, some 0 ohm resistor to create the connectivity between digital and analog, or you can place Farad bead as well, right? So again, there are a lot of options to isolate the digital and analog ground. But yeah, I always recommend just cross this section, and this section should be connected to ground, and all this section will be isolated. So the return path will be directed toward there. You're getting it? So whatever the digital return path is, it will not cross from here, right? It will go from this section, right? So all the analog information will be kind of, its digital path will not interact with analog part, right? Okay. So we did that for ground. Now the next step is you have to just copy this, paste it here. Hold on. Okay, just make this connection really thick. Okay, why I can't select the layout? Hold on. Okay, let's go for 1 mm. Okay, sorry, I just changed the length. Okay, 1 mm is really thick. Hold on. Let's go for the same width of the this thing, the diameter of the via. So that is 0.8, right? So just press tab, just 0.8 mm. Okay, now it's fine. So you have to do that for this thing. Okay, here for ground, and like you have to consider these option as well, right? So how you can change that? There will be like plane connect option. Say, sorry, it's for this one, right? Power plane connect. And here right now, this is the expansion width, which is around 0.5. Okay, and this is the air gap between that. Okay, so generally for ground, I don't want this. Okay, so you can create multiple you can say design rule for this plane connect. Okay, so I'm just going to create new rule and just assign it for a particular net, which is ground, and I'm I'm just going to use direct connection. Okay, and this is for plain connect for ground. Okay, and the reason of doing this is, I mean, see, I don't want to plan the I just don't want to take care of the multiple current ratings, right? Because see, whenever we're going to place the ground nets, or you can say the connectivity between the component and the ground plane, right? We have to always think of, okay, this, whatever the connections, which is whatever the air gap is, whatever the connections between the via and the plane is, okay, they can able to take that amount of current or not, right? So I just don't want to think about it for every via that I'm going to place, right? So for ground, I'm just going to use this thing, and for power, we can plan it. Okay, so okay, so now this is fine. Similarly, you have to just copy this and just keep doing that for all these nets. Okay, so this is a kind of very thick connection that I am placing here. You can correct that if you want. Okay, so here we have to reduce the width because it is kind of coming very close to others. So let's go for 0.5 like previous. So see, here I have two options. Either I can connect it like this, okay, or I can just, because we have space, I'll just place a dedicated via for this ground pad, right? And this is a kind of good option. I just don't want to travel the, or you can say transmit the ground current to any distance, right? I just want it directly going to the ground plane. That's it, right? So just follow this thing, and obviously you have to tent all these vias, so that you can do later as well after the layout. But yeah, this is the kind of example. Okay, let's place for this as well. For now, I'm just going to place one via only, because that I used to think about that later when I'll be reviewing the design. Right. For now, the first targeted, we have to remove all the open connections, right? So let's do that first. Okay, one more thing. These are coming very closer to this one. Okay, I'll shift that, or you can just select all together. Let's see. Okay, so there should be like minimum 0.5 mm gap between this line. This is the edge, right? This is the board cutout, right? So this thing, or you can place this board outline as well, so that you can define from here, create primitive from board shape. Right, this is the thing, and here you have to select the keep out layer, and here you can enter the information, right? So this will just keep out everything from this you can say the edge of the board, right? And there are a lot of other options as well. I just made a very detailed tutorial on this, so you can watch if you want. Okay, so for example this one, so it is like overlapping with this thing, right? So you have to firstly unlock this and shift little bit inside, right? That you have to do, that you can do later as well. But yeah, you can increase the keep out to 0.5 if you want. But yeah, that would be again huge. Similarly for these ground, you have to connect a small, so let's go for 10 mil. And here we can place small vias, or for now just place these, no issue. All right. So we can place vias here. It's because all the nets are almost same, and or if you want, you can reduce the size of the vias. Okay, so I just want to demonstrate quickly. Okay, this is a block wise connection. Okay, when everything will be connected apart from all the connection which is coming out from here or going to some other block, right? So this is one block wise connection. Similarly, you have to do the block wise connections for all the blocks, right? So after that, you will realize the position of each and every component is fixed. Okay, then you can go for another stage, which is the intra block connections, right? So that will be the connection between this SD card and SoC, right? So where all these connections are going, you have to just find a way, or you have to change the layer by placing the vias, right? And on those, either it can be layer 1 or layer 3, you have to plan it accordingly, right? And you have to route all these connections. So again, that is the first thing. So when you'll connect all the connections and all the connections inside the block, when you'll finish that, you'll realize everything is connected now. Okay, everything is connected properly, right? Okay, so let's note down the another step. What you have to do when you'll finish this. Okay, hold on, let me merge this. Okay, so for this step, we have connected the blockwise layout. Okay, another step will be connect blocks together. Another step will be length match of other things, right? So I'm just going to list down what are the other interfaces that require length match. Okay, and now length match. So you can see we have routed everything. We know where are vias, we know where are all the components. So at this stage, when we will do the length match, that length match will almost final until your reviewer will not find any issue on the things. So then you have to again adjust the length match if required, right? Now I'm just going to write down which interfaces that require length matching. Okay, so interfaces required length matching. So again, for LPDDR4 it's required, we know that. Apart from that, for eMMC it's required. Third is HDMI. Fourth is EDP. It's also required for EDP. It's also required for MIPI, CSI and DSI. Seven, it's also required for eMMC. Okay, eMMC I already noted down. Okay, PCI. Seventh is SDMMC. Okay, eighth is SDIO. Ninth is Type C. So on Type C we have auxiliary pins, right? So those pins will be the reference. Okay, if we have clock, then clock will be the reference, right? Apart from that, we have MAC. Okay, so MAC will be also after MAC we have one more, that is USB. So on USB, okay, so I'm saying USB should be length match. So I'm talking about inter-differential pair, right? So both differential pair should be length match of the USB line or wherever we are using the differential pairs. So 10th will be USB 2.0 and 11th will be SDIO. Oh, SDIO we have done that. Okay, 11th will be MAC, right? Now for all these, where you'll find the information, like for LPDDR4, right? Everything is mentioned on the impedance table. For these as well, you'll find there, right? So this for HDMI, ADP, MIPI, DSI. This for EMC, PS, VCIe, SDMMC, Type C, MAC, right? Okay, this is the thing. And from here, let me give you one example here. Okay, so talk about HDMI. Okay, so on HDMI, these are the connections we have, right? We have all the transmission lines, and we have clock. Okay, some hot plug detection and reference signal, right? And here you'll find this thing. So maximum trace length skew between the clock and data pair should be less than 80 picoseconds, right? If you want, you can convert that into, you'll find that formula. Okay, I'll share that on the group. You'll realize everything is totally like all the things which is mentioned here. This is all the information which required to convert that picosecond to length, right? But yeah, ideally we'll go for like ideal match, right? But there is a small you can say offset, right? Or you can say there's a small chance of tolerance that we can introduce on the length match if required, right? In some cases. Otherwise, just go for exact length match using the length match tool in Altium Designer, right? So you can see the data and clock will be length match. So data is what? All the transmission line, and this is the clock. So you will realize every connection on this one should be length match. Obviously for REXT and hot plug, these are the just GPIOs. REXT is the reference register for internal logic. So we have to place the register closer, on the pad. So we don't require length match here. Similarly for this one, you will find this thing, right? So you can see wherever the timing information is written, those connections should be length match. Okay. So again, you have that impedance table, so you can use this for length matching, and the block diagram as well. Okay, let's talk about power plane. For power plane, we have two power planes. Okay, I'm just going to talk about the most complicated one, which is for SOC. Okay, how we have to section the SOC power plane. Okay, I'm not talking about a single pad which needed some supply. I'm talking about the system supply and DDR supply. Okay, firstly I'm just going to split it. Let's go back to power supply page. Okay, see, this SOC is like very planned. Like it's a properly designed, and that you will realize just now. So let's start from DDR supply, okay, which is VCC DDR. If I select this, you can see this section, this particular section, right? This section is VCC DDR, right? If I'm going to okay, I didn't connected that routing thing, but on paint I can draw. All right, so let's suppose this is our RK3399, right? This is the position, right? And let's take it. Okay, so these are all the VDD DDR or VCC DDR, right? It's somewhere here, right? So that means one section of the plane, which will be something like this. I'm talking about power plane sectioning, okay? So one section of the plane, this will be assigned to VCC DDR. Okay, I'm just going to write it here. All right, let's see another one. Another one is, just go to the supply page. Okay, I'm not going to talk about logic for now. Let's talk about the big CPU. Okay, you realize just after the VDDR, we have VDD CPU big for on this section. Okay, I'm just going to just place that as well. So that is, which is on this section, right? So this is one section of the power plane, and let's name it CPU big, right? Okay, all right. After CPU big, let's go for CPU L, and this is just after the CPU big. Okay, so that means if I'll go back to paint, that means this section of the RK3399. Okay, this is another net of power supply, which is CPU big. Sorry, CPU L. All right. Okay, let's see another one. Let's talk about GPU. Okay, so you can see this whole section is GPU, right? Okay, let's draw that as well. So this whole section is, okay, hold on, this whole section is GPU. All right. Okay, let's see what else. After VDD GPU, we have VDD logic, which is here, and VDD center, which is here, right? So that means, see, this section is blocked, this section is blocked, right? This GPU section is blocked. All right. Now you'll realize why I'm using this two power planes here, right? And this section is, which is VDD logic, this is also blocked, and VDD center is here, right? See, let me draw that as well. So this is VDD logic, and here we have VDD center, just between all the power pads, and that is VDD center, right? So this is, again, this is the sectioning of the power plane, and we have PMIC here, right? So that means everything from here, like one will be connected like this, and GPU will be going directly, that we can see from the placement itself. So if I'll go back to this one, okay, where this one is going, you can see. So when we'll kind of assign this section of the power plane VDD DDR, you can see we can able to power up all the VDD DDRs here, right? So that means this is perfect. Okay, apart from that, this is for I guess big CPU, right? So where that big CPU is going, we have dedicated you can say buck converter for big CPU, right? So it is going like this, right? Where little CPU is going, we have dedicated. Okay, so again, this thing we have to place. Okay, so this is a part of the PMIC, right? So this will be going from here. You're getting it? Okay. And now let's take this one. Where logic is going. Okay, this is okay, this is logic, right? Okay, what is happening? Okay, that is for GPU. Why these all are highlighting together? Okay, hold on, I have to select from here. There's some issue with the software, I don't know. Okay, so you can see these are all highlighted. So this is the center, right? So center will be coming from another power plane, right? For example, power plane 1 we have used for this block, right? So VDD center will be connected on another power plane, because we will not have some space. You can see some space in this section, but when we're going to place the vias and when we're going to connect that, every space will be kind of occupied, right? So VDD center will be switched to another power plane, right? And the via size we're going to use the same, because obviously we'll have the pitch is very small between the pads. So yeah, okay. So I hope you got my point. And this will be the sectioning of power plane for SoC, right? And for other chips, because we have that, like you can define like all, as I told you, 3v3. It is a better idea to place all a thick 3v3 section of the plane around this. You're getting it? So it, like wherever the 3v3 is required, we'll just connect that directly as a, we'll just take out the branch from here, either on the top layer or at the bottom layer, and we'll use that on the section of the block, right? Okay, so this is the complete idea of finishing this board, right? So I'm just going to note down that as well. Okay, so till now length match is done. Another step, which will be step number 4, and that will be your power plane sectioning. All right. So yeah, this is the thing just I wanted to tell you. Till here I have routed all the high-speed tracks, and I did some blocks as well. I did some block wise layout as well, right? So it will take like few days, because this is the most time taking part, the length matching, right? Because when you finish the length match, then you'll realize, okay, you have to adjust something, then you have to kind of redo it. So this is one thing. Apart from, I guess I've told you, okay, this is the thing that I wanted to cover in today's session. So yeah, till here any doubt?